Good day and welcome back. Today I'm going to do a case study about the effect of dielectric on capacitance. So you can find some questions in past in the following years, which is including 2016, 17, and 2019. So for the case study today, I'm going to use the questions in 2019. So the original questions is shown here. So you are given with the area 144 centimeters square, and then the battery of 6 volt, distance 10.0 millimeter, and also the mica dielectric with the constant of 5.4. So always remember to convert all these values into the SI unit. To discuss these questions, so we're going to split them into two cases. The first one without the dielectric, and then case 2 is the capacitor with dielectric. So first thing we're going to discuss is the capacitance of these two capacitors, where the formula you have learned in chapter 13.2. So to calculate the capacitance, so you apply the formula of epsilon A divided by D. So you can get the value as shown here. So you could see that the capacitance of the capacitor with the dielectric is higher than the one without the dielectric, which is 5.4 times higher than the C0. And then you have learned how to calculate the total charge in the capacitor using the formula of Q equal to CV. And then you learn about the total energy stored in capacitor. So we have three formulas, which I personally use half CV squared. So you can use other two formula, depends on your own preference. So from here, you could see the overall picture on the capacitor. So first, without the dielectric, so it has lower capacitance, lower charge, and also lower energy stored in the capacitor. So of course, the discussion today won't be this simple. So I have encountered questions which is quite interesting. So let us see this capacitor. So we could design it in a different way. So for example, we only fill the space between the parallel plates of the capacitor with only half of it. So to solve these questions, it is actually simple if you know the method. To do this, you just treat it as an equivalent circuit with two capacitors connected in series, where C1 is the capacitor with dielectric and C2 is the one without the dielectric. So take note, both the C1 and C2 are having the same area as the previous capacitor, but they only have the half of the distance, which is 5 centimeters in this case, since both of them share the space between the parallel plates. So to calculate the effective capacitance, so we will revise the formula as we did just now. So replace the distance between the plate into D over 2, and you can get the value of the capacitance for C1. And then you do the same things for C2. And then you calculate their effective capacitance using the formula we have learned, which is C equal to reciprocal of 1 over C1 plus 1 over C2, and you will get 2.15 multiplied 10 to the power of negative 11 farad. And as for the total charge, so you repeat the same formula. And then the energy stored, so you just use the formula again and get the answer. So I think this question is quite simple for you after you know the method. So next, I'm going to do an in-depth analysis on this design. So I'm now going to derive the expressions of capacitance in terms of C0. So C0 is referring to the capacitance of a capacitor. And then we also know about capacitance of the mica capacitor as 5.4 times higher of C0. So for the partially filled capacitor, now we're going to express the capacitance of the capacitor in terms of C0. First, I'm going to find the expression of C1, where you will get 2 epsilon R multiplied C0, and you will get 10.8 C0 for this case. And then for C2, you repeat the process again, and you can get 2 C0. And then you calculate the effective capacitance of C1 and C2 in series. So you get 1.69 times the C0. So here you could see that partially filled capacitor has higher capacitance compared to the air capacitor, but lower than the fully filled mica capacitor. So we can also modify the design of the dielectric, which you can put it in this way. So I leave it to you to find out the capacitance of this design. So this is also quite simple that you only treat this design as two capacitors in parallel. So the effective capacitance of this design is equal to 3.2 C0. So I hope you can get the same answer as me. So in short, okay, so we have learned that dielectric is an insulator, that it can increase capacitance, the total charge, and the total energy stored in the capacitor. So if you are interested to solve more related questions, so you can join the Telegram channel to download the trial paper. There are two trial papers that I can suggest. So the first one is 2021 Yuhua and also 2019 Puchong. So the question in the Puchong paper might be hard, but actually it is simple to do it if you know the method. So I leave it to you to do your own self-study. So, and this concludes my discussion for today. So if you have any questions, you can ask in the comment section below, and do leave a like and subscribe my channel. I'll see you in my next video. Thank you.